So we will be joined by Cosmo Oil, Mami Kubota, the one with the green nails, and then Takashi Nagatomo. So you can see their profiles. You can grab them later and ask them some questions. And I'm Omar. I'm not Japanese, but I'll be with them, and I'll be facilitating this presentation. So they've been coming to our presentations, I think, for 4 straight years or in events now, and they are very kind to share their experience and what are the things that they've been doing, the success that they'd have. So for this time, the title says Elevating and Accelerating their Operational Excellence with the GE Vernova software. So I already did the introduction of Cosmo Oil. They're not from Texas. They speak slow, and that's their profile. Okay, so they have 3 refineries, which is a total of a little over of 300 K barrels per day. By the way, those are their sites. Something that's near Tokyo, something that's near Nagoya, and something that's near or in Osaka. Okay. Now, this is their business portfolio. The people coming up here would be from the refinery. So the Cosmo Digital Transformation Roadmap, you can grab them later during the beers and ask them, okay? But I just like to point out that they have invested a lot on their digital transformation. They're trying to build a physical twin, a process twin, and their equipment twins, hoping by 2030 they would be at a stage where they would be operating their or completing their center of excellence for the reliability. The one that's highlighted would be the GE Software's positioning there. So they are using now GE APM and Smart Signal. So with that, I think we're ready now to listen to Mami.
Okay. Thank you, my boss, Omar. My real boss is Yoshi. Please stand up, Yoshi. He decided to implement GE Vernova's APM 2 years ago. Today he is just watching and just drinking beer every night with Omar. And thank you for the award, and thank you for introduce my name. I am now very famous. Thank you so much. Yes, let's start. I will explain our integration of GE Vernova solution to Reliability Center of Excellence. At Cosmo Oil, we implemented a data platform, and we are developing different digital twin applications for the refinery. Our vision of digital twin for the refinery is very practical and relatable in real life. I'm sure you can tell that I'm Japanese, and I would not know much about Houston. So thanks to map application, I was able to understand the distance and duration to this hotel. Press to chose to eat with helpful review and recommends. Traffic information and more. This digital twin around us help us make timely informed decision. But our refinery, we have significant amount of data. Engineering, design data, operations, and reliability inspection records. Also, these data for most of the time are disparate and siloed. Statistics tell us that about 70% of time is spent in data collection and cleaning, limiting the workforce to make a timely informed decision. So we thought that if various refinery data could be orchestrated just like the map, engineer could make timely informed decision. Therefore, we implemented data platform to integrate our refinery data. And the term of digital twin may have many interpretation and application. For Cosmo Oil, linked to the virtual space, being able to quickly and easily search for necessary information, much like the map application, to support timely informed decision making. In recent years, the decline of highly skilled engineers and generational change have become issues. So, to manage this, we decided to consolidate data and monitor 3 refineries from the Reliability Center of Excellence we call RCOE. The RCOE processes will be executed by Cosmo Oil SMEs for efficient execution of SME. Sorry, I forgot. The bottom left image is the RCOE process for efficient execution of SME. We installed the 9 big board and configured a system that allows data collection and analysis through conversation with AI. I would like to show you the short video of our SME leveraging AI for extracting and analyzing routine maintenance KPIs.
RM の KPI を見せて。
The SME asked the AI, RM の KPI を見せて。In English, it means please show me the KPI of routine maintenance. So then the AI showed the KPI information for 3 refineries on 9 big board. Previously, this process was executed independently at various methods and formats by each refinery. But now, this system and method are commonly executed. We are incrementally executing data integration as we develop various use cases across different organization and function use cases. At present, we have finished 11 integrations such as EAM, engineering data, operations, safety incident, and near miss. Advanced applications such as virtual reality point cloud and street view, and reliability inspection data. Our latest integration development is GE Vernova Asset Performance Management APM and Smart Signal. This is a sample view of our data platform. As shown, you can seamlessly pull different information using EAM equipment information as the primary key to access P&ID, plot diagrams, 3D VR information. Here, APM is related to the target equipment tags and aggregates selected data. For example, equipment asset management index, health index, and asset strategy, risk analysis, RCM, FMEA, and or RBI. And external URLs to open and navigate to APM solution. This enables efficient and effective use of data, supporting our engineers' decision making. Thank you. Next, please.
Just like Mami-san, I'm sure you can tell that I am Japanese. Now I speak samurai English. I am from Sakai Refinery. I will share some use cases from our operation of GE Vernova Digital Solutions. This is use case from our RCOE and Smart Signal. At present, we are monitoring critical compressors in Sakai Refinery. The left image shows the Smart Signal screen, and on the right is a process collaborated by RCOE and Sakai Refinery. I hope you can read Japanese. Otherwise, you can ask Omar later. During the remote monitoring of our robotic equipment SME, a departure from the normal operating context observed. Here we can observe the departure of the blue trend, actual process value, and green trend, estimated process value. Smart Signal provided an early diagnostic of potential liquid carryover at priority level 2. This prompted the RCOE SME to contact Sakai Refinery and recommended further verification. As a result, it was verified that a control set point was changed. After discussing with the operations team, it was agreed to bring back the second stage suction level control set point to original value. This use case demonstrates how RCOE enables us to detect changes that conventional human monitoring would miss or will not be able to notice. Smart Signal provided early catch of potential failure modes and risk avoidance. Next. The next use case I will introduce is our application leveraging Policy Designer. 1. As demonstrated by the Pareto, almost 20% additional scope of repair goes to control valve. 2. Erosion and cavitation are the common finding of additional repairs. We investigated how to detect and act on these issues, how we can leverage APM to solve real issues at the refinery. I will explain in the next slide what we did with APM to support reduce additional scope during routine maintenance. Prior to APM implementation, we rely on our operators to detect potential control valve failure. However, timely and accurate identification is a challenge. Eventually, control valve failures happen, and we need to implement intervention while preparing for repairs. This breakdown maintenance actions causes inefficiencies and increased cost. Post-APM implementation, we leverage Policy Designer to automate detection of potential control valve failures and drive proactive actions. The bottom illustrations describe the Policy Designer configuration I did. We integrated to APM our process parameters to develop a logic identifying potential erosion and cavitation. When the mechanism is confirmed by the policy logic, an automatic email notification will be sent to maintenance and operations. These notifications are detailed enough, providing relevant information for effective. Next. The third use case I will share is our improvement in failure elimination process. At Cosmo Oil, we use failure library to identify the root cause and action during failure to prevent recurrence. Materials used in verification, evidences, and other documentations are in the possession of individual engineers. And this information or knowledge is not fully utilized handed over for record keeping or future reference. To improve our failure elimination process, we decided to enhance our exhaustive process with APM functions. Basically, we used the following. 1. Root cause analysis. Follow a common methodology and documentation. Example, event diagram, logic tree, 5 eyes. 2. Query. Self-service, easy to use utility to extract data from APM reliability and maintenance database. The next slide will describe our failure elimination process before and post APM. Prior to APM, our processes for failure elimination is resource consuming and had challenges to integrating root cause analysis results to other functions and systems. Obviously, we are not able to maximize the outcomes of failure elimination processes. This is illustrated on diagram above. Post APM, you can see on the bottom diagram, we have improved the following processes. 1. Eliminating manual process for generating hypotheses. Now, on failure events, we trigger APM RCA and use APM query to extract data. This improvement in accurate identification and prevent potential omissions. 2. Avoiding siloed information. Now we can attach to documentation and reporting links to relevant APM RCAs. These RCAs are also leveraged during equipment strategy reviews. Post-APM implementation improves work processes efficiencies. It has become possible to accumulate, share knowledge and information effectively. Next. The fourth is our use case for optimizing spares holding point. Spares analysis is one of the functions within the reliability analytics. We optimize the spare parts inventory for mechanical seal for compressors through Monte Carlo simulations. The analysis considers procurement time, failure rates, and storage cost to determine the optimal inventory. Previously, spare parts quantities were determined based on post-failure records and engineer staff judgment. The APM spares analysis resulted a recommendation that keeping 2 spare units of mechanical seal for compressors. We revised our inventory strategy accordingly, and now we should have a better method of determining our spare and optimizing cost. The last slide will be explained by Omar-san.
Okay, in summary, so they shared their use cases. So it's not the use cases, all the use cases that they have, but they have decided to select those use cases. So there were use cases for Smart Signal, how they leverage Policy Designer to automate their process, and root cause analysis using queries, and then on spares analysis they've been using on the reliability, and, to optimize their parts. Now, those are the functions that they have. The outcome, they have interpreted it as availability up, reliability up, etc., etc. And then they have also quantified it on what it means for them. So I don't know how they compute those numbers. You can ask them later. During beer, they might tell you the formula. But what is important as well is the potential actions. So they're not stopping there. They're going to continue that. They're rolling out to other equipments, other sites, and then they would have to further improve or standardize their failure elimination work processes and do these other calculations or optimizations for the spare parts that they have. So the last message is Cosmo Oil will continue to scale up and maximize the potential use of GE Vernova solutions, APM, Smart Signal, and integrations to their work processes in continuing to elevate and accelerate their reliability center of excellence. Thank you very much, and have a good part of the day, okay?